Alan, Alan, can you hear me? Did we finish notes number 5? You already forgot what we did last week. Yeah, Pong Pong said yes, we finished notes number 5 last week, right? Okay, we finished notes number 5. Let's go on to notes number 6, I guess. Okay, I'll give you notes number 6. Okay, guys, in notes number 6, in chat box, you can get our notes number 6. We want to I'm going to move on to a new topic. It's notes number 6. We need to print anything out before class. Yeah, yes. If the students is into use a hard copy, yeah, you can print out. If yes, notes number 6. Yeah. Can we get started? Notes number 6. Okay, notes number 6. Yeah, basically is we finish if we finish notes number 5 last week, that means we already finished consumer behavior. Yeah, remember earlier in the first week, I did a kind of overall introduction to microeconomics. So if you still remember that introduction, in that introduction, I mentioned that I said in macroeconomics, we totally we will learn 3 basically big topics. The first part is consumer behavior. And the last week, notes number 5, the utility maximizing equation, was the last topic of a consumer behavior. Yeah, so we basically done consumer behavior. We finish everything about consumer behavior. From this week, we will do a new topic. We will do the second part of the macroeconomics is about producer behavior. Producer behavior is the most important, most difficult part. Yeah, actually, it's the most difficult part in your macroeconomics. Yeah, why producer behavior will can be more difficult. You will, yeah, gradually you will appreciate about this. Yeah, because in producer behavior, you kind of need to consider kind of more variables. Okay, as a consumer, you only need to consider, yeah, how much money. Yeah, kind of you only need to make a decision regarding how many units of X and how many units of Y you should buy. Because last week we made a simplification that as a consumer, you only buy two different things. Okay, but your total income and the price of these two different products are given by the market. So as a consumer, you kind of only consider just one or two variables. You only need to make a decision regarding what is the optimal consumption bundle, like how many X and how many Y you should buy. Okay, but this week as a producer, you kind of need to consider more variables and to make more decisions. Okay, so what do I mean? Let's do an introduction here. So as a consumer, as a producer, what you want to do is you want to maximize. You want to maximize something called profit. And how you calculate net profit? So you guys need to tell the difference between profit and another term is called the total business revenue. This term is a totally different. Okay, profit is a kind of the real money, the real net profit you make. Okay, but how you calculate profit? So as a producer, as a business owner, you use total business revenues minus something cost as a cost. Okay. So you want to maximize some profit, something called profit. The net profit is the real money you made from your business. Is called profit. Okay, but the total business revenue is the money you received from your customers. You got it from customers. The money you got from customers does not equal to profit, right? Does not equal to net profit. Because earlier in the first week, we mentioned something called cost. You need to pay money for those resources, production factors you purchased for your production, right? Okay, you rent a shop, you rent some space, you rent a building for your Starbucks, so for your coffee shop business. You hire workers, you need to pay wage. Right? If you borrow money from a commercial bank, you need to pay interest, right? You need to pay the rent to your landlord. You see, you pay a lot of money for all the resources you purchased, you used. Okay, so you need to minus the cost here. Okay, so based on this equation, if you want to maximize the profit, okay, the first way you can increase your profit is you increase. Okay, you can increase your total business revenue. Oh, by the way, how we calculate business revenue? Yeah, how we calculate this thing called the total business revenue. We mentioned about this in notes number 3, I guess. Yeah. In notes number 3, we mentioned how to calculate business revenue. Can somebody tell me? Can somebody tell me how we can calculate total business revenue in notes number 3? Okay, no response. Okay, no response. I can answer my question. To calculate business revenue actually is a product of just a P and Q. Yeah, that's it. Super easy. How we calculate total business revenue just equal to P times Q. P is the price of your product, and the Q is how many units you can produce and you can sell. Okay, quantity of output. Okay, so equals to P and Q, yeah. Business revenue equals to P times Q. Okay, it's the product of the P and Q. Okay, to maximize, to increase your net profit as much as possible. So further thing you can do, you should increase your business revenue. Okay, another way you can do is maybe you can lower your cost. Okay, you can increase your profit by lowering your cost. Right? If you can increase the business revenue, lower your cost, so you can maximize your profit. Because the profit is a difference. It's the difference between these two variables. Okay, then my next question is, so why I say in the beginning of today's lecture, I say producer behavior is more complicated because you need to kind of make two decisions. You need to consider these two variables. Okay, the first question is, okay, how you set the price for your products. Okay, how many dollars? Yeah, how big is the price you should charge from your consumers? You need to do something called the pricing strategy. Okay, you need to do something called the pricing strategy because you as a consumer, you as a producer, you need to determine, yeah, what is the price of your product, right? Like if you are the company, Apple company, you really need to consider, yeah, what is the price of the new iPhone? Okay, it's called iPhone 15. Yeah, what should the price be? There should be $1,000, $2,000, or $3,000. You need to make a decision here. So this part is called the pricing strategy. We actually have learned, something, a little bit of something regarding how to make a pricing strategy. Still in notes number 3, when we learn elasticity. Can somebody tell me what we learned in notes number 3? How we can make a good pricing strategy? Like you need to know in what kinds of situation you should increase the price, in what kinds of situation you should lower the price. And this kind of decision here has somewhat relationship with the price elasticity, demand elasticity for price. So how we make a decision regarding how to set the price based on ED information. ED is demand elasticity of a price. And no response. Okay, but no response. I can answer. I can answer my question is in notes number 3, we learned about this. Okay, how to do a good pricing strategy. The first thing is ED is a very useful information. We learned about this. Okay, if ED greater than 1. So what do I mean by ED greater than 1? ED greater than 1 means your targeted consumers, they care about price change. Okay, they are sensitive about price change. Okay, if they are sensitive about price change, then ED greater than 1, we should decrease our price, right? Because all your targeted consumers, they care about price change. If you can lower your price a little bit, then the total revenue will increase. Okay, so this is called ED greater than 1. So by contrast, what about ED less than 1? So if your targeted consumers, they don't care about price changes, they are not sensitive about price change, how you can make more money? How you can increase your total revenue? Increase the price or lower the price? If they don't care about price change, think about that. All your targeted consumers, they don't care about price change. Okay, so this time we should increase the price, right? If they don't care about price change. And this time we increase the price, so total revenue will increase. Okay. Okay, so yeah, this is what we learned from notes number 3. You guys should already know this part. Yeah, from notes number 3, we learned about these things. Yeah, once again, ED is a very useful information for making a good pricing strategy. So number 2, actually from in next week, okay, we will learn basically new term, something called market power. Okay, market power also can be called as something called a pricing power. So basically, whether or not you can make a good pricing strategy really depends on whether or not your firm has something called market power or pricing power. Yeah, but market power, pricing power is the topic we will carry in the next week. Okay, so this week we don't we will don't talk about a lot of things about these two. Yeah, but today we actually need to focus on another determinant of your total business revenue is called Q. That's a okay, it's called Q. Okay, so my question actually into is worth your attention is how we increase the business revenue. Okay, by alternating your Q. Okay, how you choose the optimal quantity to increase your business revenue. Some of you may think, okay, bigger Q means a higher level business revenue, right? Some of you may think about this. Bigger Q, higher level Q. If we produce a lot of things, a lot of goods and services, yeah, maybe the total revenue can be increased. Okay, so my question is that always right? Okay, does a higher level production quantity always lead to higher level business revenue? Yes or no? Does a higher level quantity always lead to? Okay, the answer for this question actually should be no. Okay, actually should be no, because one explanation, maybe is if you can produce a lot of things, yeah, maybe you cannot sell all of them, right? If you produce a lot of things. Yeah, this is a one common answer, yeah, from students for this question. Okay, but my way, the second way, okay, to explain this question is, okay, we need to take a look. Okay, this is the biggest topic we need to figure out in today's lecture. Actually, there is a close relationship. Let's change in another color. There is a relationship between Q and cost. Right, there is a relationship between Q, quantity of output, and your total cost. Actually, shouldn't be total cost. Okay, I want to talk about the quantity of output and the average total cost. Okay, like a total cost per product. Okay, why in the introduction part I said producer behavior is more complicated? Okay, because mathematically speaking, in this part, in this chapter, we will use more kind of a quadratic function. Okay, we no longer learn like in the first chapter in the consumer behavior, the relationship between P and the supply between P and D always a simple linear relationship. Okay, but in the second chapter, we will learn more about like a curve relationship, not like a straight line, simple straight line relationship. Okay, for example, the relationship between quantity of output and the total cost per unit. So it's called ATC. It's not a linear, simple linear relationship, but it's a kind of a upward parabola. It's a curve relationship. So I mean, if I build a coordinate system here, if I label the horizontal line by quantity of output. Okay, like I just use my horizontal line to represent how many units may be coffee. Imagine you are Starbucks. Okay, you are just a Starbucks. Okay, the horizontal line is the quantity of output. Okay, because we are talking about the cost, the unit of cost just is a dollar sign. Okay, so I just put a dollar sign here. Okay, so ATC, okay, cost per unit. Okay, in later in our formal lecture, we can be called as the ATC, average total cost. The relationship between Q and ATC isn't a simple linear relationship. Okay, not just look like your supply curve and the demand curve. Okay, but this time it should be a upward parabola. Okay, like this. Okay, your ATC in the first stage, yeah, due to some reason will decrease. Okay, and finally your ATC will increase. Okay, so today the most important question, the most important problem we need to deal with in today's lecture is why ATC? Why does ATC look like this? Okay, why does ATC? Okay, isn't a simple linear like a straight line? Why ATC is a curve? Okay, but not a simple linear relationship. Okay, we will figure this question in our class notes step by step in greater details. Okay, but given by this question, my last question in of this introduction part is where is the if we don't consider about price, okay, because in this graph we don't build the price information into our model. In this graph model, we only can see the relationship between how many units you produce and something called ATC, right? So my question is where I should produce. Where is the so-called optimal production level? Okay, so maybe I can give you three. Okay, you got the choices here. Okay, if you produce at a Q number 1, okay, so your average total cost is here, right? So if you produce like a Q number 2, okay, so that means your ATC is here. So if you produce a really, really large quantity, we label this one by Q number 3. Okay, which one you should produce? Where is the optimal production level? If I give your ATC look like this, should you choose the Q number 1, Q number 2, Q number 3? Okay, so maybe Alan, where you should produce number three. Why? Why you choose the queue number three? Oh, why you think we should choose queue number three? We when we talking about this equation, we mentioned that we want to lower your cost, right? As a business owner, you want to lower the cost. You want to lower the cost. Okay, so we which production level can lead to a lower total cost per unit? So the answer should be Q number two. Yeah, when you produce at a Q number two, you see, okay, the corresponding ATC is at the lowest level. Yeah, so this production level is what we want. Yeah, because the corresponding ATC is at the lowest level. That means you can save money, right? You can save money as your production cost. Okay, if you produce just a little, just a few units when your production is super low, your ATC is very high, the cost per unit is pretty high. Yeah, but if you produce a lot of things, a higher production level also can lead to higher level ATC. Okay, so Q number two. So far, we don't have the price information. So far, by producing Q number two, you can minimize, okay, you can minimize the total cost. Okay, so that is what we want. Yeah, so it's a Q number two. Okay, so basically this is a basic introduction of a so-called producer behavior. Okay, producer behavior. Okay, but once again, today the most important question, okay, is about the relationship between Q and the cost. And be more specific, we want to talk about the quantity of output. So Q here means, okay, it's actually it's called quantity of output and the so-called ATC. Okay, and another curve is called the total cost per unit. Okay, and the most important thing we mentioned so many times, okay, is why the relationship between Q of output and ATC look like this. Okay, it's represented by a quadratic function, represented by a curve, isn't it no longer is a simple linear curve. Yeah, this is the most important question. So let's get started. Okay, I'm a formal lecture. So to answer this question, the first step is to tell the difference between short run and long run analysis. Okay, it's called the short run and long run analysis. So first remember this, okay, in the field of economics, short run and long run. Short run and long run, the difference between short run and long run is not related to a kind of a cutoff. Okay, we are not talking about like something will happen within 1 year. Okay, if less than 1 year is called a short run. Okay, something will happen in 2 years, that is called a long run. That's wrong. Okay, there is no like a cutoff in timing. Okay, there is no cutoff to tell the difference between short run and long run. So then what is the difference? What is really the difference between short run and long run analysis? Let's explain by this once again by telling a story. Okay, imagine you are just imagine you are a Starbucks. Okay, you want to build your own coffee business. So my first question is, what kind of resources you need? What is the resources you need to build your own coffee business? You're just like a Starbucks. So in real life, you need to use a lot of different things. You actually mentioned today you need to hire workers. You need to rent a building, rent a shop, rent some space for your business. You need to buy a lot of all different types of raw materials you need. Yeah, all the things you need to. But for a simplified question, we just assume we just use three different things. Yeah, for making. Okay, to make this question easier, okay, we only use three different types of resources. Okay, resources also can be called the factors. There's three different factors I need to use. Okay, just three. Okay, the first one, okay, imagine I need to build a building, or I rent a building, or I build my own building. Okay, I use this little building here. Okay, as my coffee shop. Yeah. So I need some space for my coffee shop. Number two, I hire workers. Okay, just a manpower, just a human resources. So number three, I just need to buy some coffee beans. Yeah, this is my coffee beans. Okay, easy, right? Okay, for simplification, this is just assumption. I know in real life, you need to use a lot of different things. Okay, but in our model, in our game, okay, we just use these three different things. Okay, coffee beans, workers, and a building. Okay, to combine these three different things together, I can produce coffee. I can produce boiled total coffee for my consumers. Okay, then the next step, if no questions, okay, I will do this. For each and every type of a resource, okay, I can use a number. I can just use a number. And the corresponding and the associated unit, okay, to describe, to count, to describe something called input amount. Or something called usage, maybe can be called. Okay, what do you mean by input amount? Like how many each and every type of resources you needed to use? Okay, maybe per month, maybe for every month. Okay, how big is the usage of each and every type of resources? I can count, right? I can measure. Okay, so for example, like how big is the building, right? Input amount, to describe the input amount, I'm talking about how big is the building. So let's see, randomly speaking, let's see, my building is 500 maybe square feet. A square feet, known as here. Right, I'm talking about how big is the building. Okay, this is my so-called input amount of the first production factor is called building. Okay. Okay, okay, next question, how many workers I need to use? I need to hire, I need to input. Okay, let's see, totally we have 3 workers or 5 workers, 5 persons. You see, once again, I'm using a number and the corresponding unit, okay, to describe something called the input amount. How big is the usage for each and every type of resources? Then my second example is that I totally hired 5 workers, just a five person. How many units of coffee beans? The last question. How many units of coffee beans into input into use? Yeah, for every month. Okay, let's do maybe 100 kilogram, 100 kg. You see, these are three examples. Okay, 500 square feet, 5 workers, 100 kg. Okay, is a so-called input amount or the usage. Okay, for every type of resources you need. Okay, then the last step. Okay, then the last step. You need to consider this question. Due to there is a physically in real life, physically there is a big difference. Yeah, between this yeah, each type of resources you need, right? So the next question, yeah, how long, how easily you can increase the input amount is also different. Okay, now I want to increase the usage. I want to increase the input amount. Basically, I want to buy more resources, use more resources. Because maybe due to some reason, I'm predicting the demand for my coffee products will increase. Maybe due to coming long weekend. So as a business owner, yeah, based on my previous experiences, I'm predicting I will have more. I will got more customers in coming long weekend. So what I want to do is I want to increase the input amount to produce more coffee. Yeah, to produce more coffee, I need to buy more resources, right? So you want to increase the input amount, but how long you need, for example, to buy coffee beans? How long you need to buy coffee beans? Yeah, imagine I just buy coffee beans from Costco. Yeah. Imagine I just buy my coffee beans from Costco. So what I do, I just drive my car. I head to Costco, buy coffee beans. So give me just a 1 hour. I can buy my coffee beans. So how long I need to increase the info of coffee beans in just a 1 hour? You see, in shorter period of time. Okay, it is a kind of a more easily. Yeah, it is easily to increase the input amount of coffee beans. Okay, how about workers? How long by this time? Next question is how long I need to hire one more workers? If 5 workers is not enough, I need to add more manpower. So how long I need to hire one more worker? Can I hire one more worker within 1 hour? Like 10 hours? Yeah, maybe 10 hours is not enough because in real life, yeah, think about this as a business owner, how you hire workers. Is the process maybe is a very time consuming, right? Maybe you need to post an advertisement on the website somewhere. See, I'm hiring people, I'm hiring workers. You got a lot of resumes. You do selection, you do interview, you need to negotiate the employment contract with the candidates. You do training, right? You do a lot of the things for hiring more manpower. Yeah. So how long you need to do that? Let's say maybe 1 month. You see, I mean, talking about within 1 hour, it is impossible, right? It is impossible to add more human resources illegally. Yeah, you need to finish all that very long process. Okay, so this time let's see randomly speaking to use 1 month. Yeah, average speaking with 1 month, you can add more manpower. Then the next question is how if 500 square feet is not enough for my coffee business. So what we can do? So maybe I need to rebuild the house, right? Rebuild the building to enlarge the building. So how long I need to enlarge the building? How can I rebuild this building within 1 month? Yeah, maybe 5 years. Yeah, let's do 5 years. You see? Yeah, because Canada is slow. Yeah, yeah, super slow. Yeah, if not slow, it's super slow. Okay, so after I done this story, hopefully you guys can get the idea. Okay, I mean, for some type of resources, it is easily within shorter period of time. Okay, just using little effort, you can increase the usage, you can increase the input amount, you can prepare more resources for your business within shorter period of time. But for some type of resources like this building here, it is so difficult to increase the input amount. Yeah, to increase the usage. Then you can tell the difference between the short run, tell the difference between the short run and the long run analysis. So what is a short run? What is a short run? Once again, long run or short run, these two terms here do not refer to a specific cutoff. Okay, we are not talking about if longer than 1 year is called a long run, shorter than 1 year is a short run. No, that's wrong. Then what is a short run? In short run analysis, if you are doing a short run question, remember this, at least one production factor is fixed. Okay, the most difficult to change the usage, to increase the amount, that resources is fixed in short run period. Okay, but all other factors can be called as a variable resource, variable factor. Okay, the input amount is fixed. Okay, so that factor is called fixed, can be called as a fixed factor. But in long run, if you get enough time, we don't need to specify how long is a long run, okay? We don't need to specify how long it can be called as a long run. Okay, if you got, just imagine if you got enough time, okay, you can increase the input amount of everything you need. In that type of a situation, that is a long run analysis. Okay, one more word finally. In long run, all the resources are variable resources in long run. Okay, but in the short run analysis, at least one production factor is fixed. For example, in my story, maybe the building. Okay, maybe the area of the building is fixed. Within shorter period of time, you don't have enough time to enlarge this building, so it's fixed. Okay, but you can hire more workers, you can buy more coffee beans within short run period. Okay, but you cannot enlarge this building, rebuild this building, okay? Because this is only a short run analysis. Okay, so if no questions, okay, let's do short run analysis. Okay, the most difficult part is the short run analysis. Okay, to take AP level examination, actually you don't need to pay a lot of attention to long run analysis. Long run analysis is easy. Okay, but the short run analysis is difficult. Okay, let's do this step by step. In short run analysis, okay, the most important thing, okay, is called law of diminishing marginal return. Law of diminishing marginal return is talking about the relationship between variable input level. How many units of a variable input you use, and the production curves. Okay, let's have an example here. So if you turn to the next page, you got a table here. Okay, in my last example, in my last story, Okay, I use the three different types of resources, right? Building, manpower, human resources, and capital goods. No. And the coffee beans, sorry, yeah. For this, for here, for this table, for this business, okay, let's change the assumption a little bit, okay? K equals to 3 is fixed. Okay, what do I mean by K? K means capital. In the field of economics, we usually use the uppercase letter K to denote capital. Capital, what is a capital? In the first week, we learned about this. Capital is refers to machinery, equipment, tools into use to do the production. So for my coffee shop, if I say K equals 3 is a fix, that means, okay, for example, I only have 3 coffee makers. Okay, this is 3 coffee makers are fixed. Okay, I just assuming within shorter period of time, I cannot get more coffee makers. Okay, but labor is a variable. Okay, if I say labor is a variable, by seeing this, I mean within shorter period of time, you can hire more workers. Okay, but 3 coffee makers, yeah, is a fix. Yeah, maybe your coffee makers are so special. Maybe we need to import coffee makers from Italy. So within shorter period of time, yeah, maybe we cannot get more coffee makers. So 3 coffee makers is a fix, and the labor is a variable. That's it. We only use this example even more simpler, right? Because we only use 2 different things. Okay, we don't need a building assuming. We don't need a building. Okay, just a K and L. Okay. Okay, let's get started. Okay, let's get started. Okay, in the first day, okay, in the first day of your business, okay, you hire nobody. So first column here, indicating how many units of labor you hire, how many units of workers you hire. Okay, so you can hire, for example, you can hire nobody. You can hire just 1 worker, 2 workers, 3 workers, 5, 4, 5, 5, 6, blah, blah, blah. Yeah, first column indicates how many units of labor now you hired for your business. Yeah, okay. So the second column is called TP. So TP means the total product, the total production. How many units of coffee, how many units of products totally you can produce. Okay, marginal product. Okay, so let's get started. If you in the first day of a business, when you hire nobody, no labor, no manpower, and you only have 3 coffee makers, how many units you can produce? 0. 0, because no labor hired. You cannot only use the coffee makers to produce coffee. Okay, so if you hire nobody, the TP equals 0. Okay, next day on the second day of a business, you hired your first unit of worker. So totally you hired just a 1. Okay, just a 1 unit of labor here. So how many units of this guy he or she can produce? Maybe per hour. Let's say 5 units of coffee. Okay, so I put 5 here. So what is a marginal production? Marginal production is additional products you can produce by hiring just 1 more unit of labor. Just by hiring 1 more unit of labor, how many units of additional products you can produce, okay, is called MP. Is called MP, okay, is called marginal product. Okay, last column is called AP average product. What is AP average product? Okay, how many units of products you can produce per person per labor? Okay, so how you calculate AP? You just take AP divided by how many units of labor you hire, right? So 5 divided by 1, so equals to 5 here. Okay, 5 divided by 1 equals to 5. Okay, so let's move on, right? Because you got 3 coffee makers. When you hire just one labor, yeah, so naturally, yeah, naturally you know you can hire more laborers, right? So let's say add more manpower. So when you hire the second of a labor, so totally you got 2 workers higher. Yeah, totally you got 2 workers higher. So totally now you can produce 20 units. Be very, very careful here, okay? Everybody, be very, very careful here. If you hire 2 units of worker, totally you can produce 20 instead of 10. Some of you may think, okay, if the first guy can produce 5 units, and now you hire totally 2 units of labor. So 2 units of labor, so 5 for each, so totally should be 10. That's wrong. That's totally wrong. So when you hire 2 units of labor, you see the real data, okay, the real data is the TP has been increased to totally 20 instead of 10. Okay, that means the marginal production of the second year for labor is 15, because you do 20 minus 5 equals 15. So what is the AP here? So total TP divided by Q. So 20 divided by 2 equals 10. So 10 units of products per person, per worker. Okay, let's do one more. Okay, let's do one more calculation. When you got the third year for labors, so totally all your team here, now you got 3 workers. So totally they can produce 45. So next step, you do 45 minus 20. So marginal production is 25. By hiring the third unit of labor, after you already got 2 units of labor, by hiring just one more unit of labor, the MP for the third unit of labor is 25. So how I can get 15 here? So you do 45 divided by 3. 45 divided by 3. So it's 15 units, okay, per person, right? Okay, so from 0 to 3, let's add one more labor here. Okay, from 0 to 3. So this is a kind of the first stage of our overall production process. So this one can be called as increasing marginal return. Okay, so what do I mean by IMR? IMR, okay, means something called increasing marginal returns. Okay, increasing marginal return. I mean, based on this table from 0 to 3, okay, we can get a pattern here. Why? Because from 0 to 3, you see marginal production increases. Right, from 0 to 3, from 0 to 3, you see marginal production increases from 5 to 15 to 25. When you can hire more workers, MP marginal production increases. Yeah, marginal production increases. Okay, due to marginal production increases, yeah, when you hire additional laborers, those additional laborers, right? For example, the second labor, the third labor, they can bring out more units. They can bring out more units due to some reason. So the total production, So the total production increases with an increasing rate. What do you mean by increasing with an increasing rate? It just increases faster and faster. Okay, so this is called increase. Okay, faster and faster. This is called increases, but slower and slower. Okay, because the further curve here, okay, becomes more steeper. Okay, so that means yeah, increases faster and faster. Or we can say increase with an increasing rate. Because the second one is increases by decreasing rate. So increase, still increasing, but slower and slower. Okay, so from 0 to 3, okay, from 0 to 3 is called the increase in margin rate. Okay, let's continue. Okay, let's continue. When we add the first unit for labor, when we add the first unit for labor, so totally the labor of the labor have higher, right, comes to 4 units. Okay, so the total production, say if it's a 6T, so you see marginal production here begin to decrease. So maybe you change in another color. Okay, 517. Okay, 6 is 72. Okay, so the marginal production you see decreases from 15 to 10 because you do 70 minus 60. So 10 here, 2 here, you see marginal production began to decrease. But in the second stage, still greater than 0, then where is the second stage? From 4 to 6. So we label this one by decreasing marginal return. So it can be called as can be labeled by NMR. Okay, NMR means negative marginal return. No. DMR, so decreasing marginal return. The third stage is called the lesser row is NMR. Okay, D just means decreasing, a decreasing marginal return. Yeah, because now the marginal production begin to decrease. Okay, then the lesser part. Okay, then the lesser part. Finally, when you add this, when you hire one more unit of labor, that is the 7th of human labor. You see, the 7th unit of labor cannot bring out more products. After you hire the 7th unit for labor, the total production began to decrease, and the marginal production finally become a negative, becoming a negative number. So this part, the lesser row here is called NMR, negative marginal return. Okay, one more arrow here. So this one, so because the marginal production began to decrease, so decreasing marginal return. So how we so the total production should be increased with a decreasing rate. So just increase slower and slower. My last question about this table is that if these data points are reliable, they are true data points we collected from real business world, then the reason is why, especially for the first thing called AMR. My question was, so if one unit of labor can produce 5 units, okay, that means the 2 units of labor can produce 10, right? That means the 3 units of labor totally can produce 15. But why in the real business world, when you do 2 units of labor, you can produce 20? Why if the total 3 units of labor can produce 15? What is the reason? Why is that the case? What is the reason? Nobody want to join? If nobody want to join, let's is this is a actually it's a hard question, right? This is a hard question. So what we can do, we can maybe we can watch a video. Remember, I got a video here. So after you watch this video, yeah, maybe you can get some idea from this video. So here, okay, guys, let's watch a video. So can you
Friend of Ford's once compared him to a kind of boxer, tiptoeing and dancing around the factory.
let's watch a video, okay? Let's watch a video. Then let's get started.
Friend of Ford's once compared him to a kind of boxer, tiptoeing and dancing around the factory floor all the time, thinking about what could we do here, what could we do there, how could we change the production process to make the car better and cheaper and bring out even more of them.
While they're groping about for improvement, someone begins to think about the meatpacking plant where the carcass of a hog or a cow is hung on a conveyor and moves through the plant past meat cutters who cut pieces off the animal. What if we turn that around? What if we put in some machine that we want to assemble and we move it past people and we have people put things on?
Ford's team tried out the idea in the flywheel magneto department, where the device that generated electricity for the ignition system was made. Rather than having one person build a coil at a time, the supervisor broke down the individual tasks into a sequence driven by a conveyor. The new system reduced the time it took to make a magneto from 20 minutes to 13 minutes, 10 seconds.
And then somebody says, well, if it works on magnetos, what about transmissions? What about axles? Well, what about engines? Productivity goes way up. Time to produce a car goes down. And they realize we're really on to something.
Under the old stationary system, the record time for assembling a car had been 12 hours and 13 minutes. Using the assembly line process, it took 1 hour and 33 minutes. By the fall of 1913, Ford had established the first automobile assembly line in the world.
Henry Ford is
Can somebody make a kind of a summary regarding what we learned from this video? What we learned from this video, guys? like how the Ford company, do you guys know Ford company? I heard like a Ford did something. So what they did? Make cars really quick. Yes, that's right. Yeah, how they make cars really quick. Yeah, how the new stationary system okay can be more productive. Can be more productive. Yeah, why? What is the reason? Yeah, how they can produce the cars more quickly, like before they improve their stationary system, yeah, how long they to produce a car? I heard it's a 12 hours, right? 12 hours into 12 hours to assemble to produce a car kind of. Yeah, after they did some kind of improvement for their stationary system, how long they to produce a car? Just 1 hour 33 minutes. Wow, they can produce a cars more way more quicker. Yeah. How what they did? Why they can produce a car more quickly? So we need to we need to play the video one more time.
Extremely relevant to us today in
Okay, let's watch a video again. Let's try to find the answer. Okay, why they can produce a car like a really fast? What?
Kind of Ford once compared him to a kind of boxer, tiptoeing and dancing around the factory floor all the time, thinking about what could we do here, what could we do there, how could we change the production process to make the car better and cheaper and bring out even more of them.
While they're groping about for improvement, someone begins to think about the meatpacking plant where the carcass of a hog or cow is hung on a conveyor and moves through the plant past meat cutters who cut pieces off the animal. What if we turn that around? What if we put in some machine that we want to assemble and we move it past people and we have people put things on?
Ford's team tried out the idea in the flywheel magneto department, where the device that generated electricity for the ignition system was made. Rather than having one person.
Okay, guys, be careful here. Okay, be careful here. Here is the answer. Okay, let's pay attention to this part. Instead of, let's get started from the instead of.
Person build a coil at a time. Coil at a time. The supervisor broke down the individual tasks into a sequence driven by a conveyor. The new system reduced the time it took to make a magneto from 20 minutes to 13 minutes, 10 seconds.
And then somebody says, well, if it works on magnetos, what about transmissions? What about axles? Well, what about engines? Productivity goes way up. Time to produce a car goes down. And they realize we're really on to something.
Under the old stationary system, the record time for assembling a car had been 12 hours and 13 minutes. Using the assembly line process, it took 1 hour and 33 minutes. By the fall of 1913, Ford had established the first automobile assembly line in the world.
Okay, guys, the real things we learned this video is when you can hire more workers, when you can hire more workers, you need to reorganize the way regarding how you produce your products. Okay, if you only can hire just one unit of labor, okay, then you need to use the labor to produce the products kind of from the beginning to the end, because you only have one labor. So this labor, he or she really needs to produce the product individually. Right? So the first unit worker, if the first unit worker is the only worker you hired, okay, so he or she, the first unit worker, really needs to produce the whole thing. Okay, from the beginning to the end individually. Okay, but when you can get the second for labor, third for labor, right? What we learned from this video is instead of let just let everybody to produce their products individually. So what you can do, we can break down, right? We can divide it, the whole products into different parts. Okay, maybe to produce a car, yeah, we can divide it the whole car, whole thing into three different parts, like a part A, or part B, part C. Yeah, maybe this is called engine. Maybe this is called the chassis of the car. Maybe this one is the four wheels of the car. Okay, let the first unit of labor focus on part A, and let the second unit of labor focus on part B. Okay, let the third unit of labor focus on part C, and then we use a conveyor to combine the part A, B, C together to build our car, to build the whole car. Okay, so if we do this assembly line, right, we learned from the video, the first they did something called assembly line. The overall production process can be more and more productive. Right, one idea, one explanation here is you don't need, as a worker, you don't need to know how to produce the whole car, the whole thing, right? You only need to know how to produce, how to be good at producing engine. Right, if the scope of your production, scope of your work can be, if you can narrow down your work a little bit, you can accumulate your working experience really fast. Okay, so the overall the factory's stationary system can be very the productivity can be increased really by a lot, right? What we learned from this video is that before they do this conveyor assembly line, how long they need to build a car, produce a car, maybe 12 hours. After we do this thing, actually this process is called labor specialization. Okay, after we do something called labor specialization, we can what? We can produce a car actually within 2 hours, right? Because of 1 hour 33 minutes. Okay, so this is a reason, okay, this is a reason why, once again, why marginal production can be increased here when total production increase faster and faster. And the next question is super easy. Why after 3 units of labor, why production begin to decrease? Can somebody give me the answer? So this question is easier, right? You can easily guess. Why marginal production begins to decrease after you hire the first unit of labor? Nobody want to answer. So actually, the answer is a super easy. Yeah, cause I still remember our assumption here. So my assumption is a k equals to 3 and is a fixed number. Okay, you can hire more laborers, but k fixed at 3. I mean, within shorter period of time, you cannot get more coffee makers. So actually, the answer is easy. Why your productivity, why your efficiency of your business begin to decrease here? Because we are overusing the fixed resources. So just because the coffee makers 3 units is not enough. It's not enough for more people. Yeah. As 3 coffee makers is not enough for totally 4 units of labor, 5 units of labor, 6 units of labor, right? So more people, yeah, because due to more people are overusing the fixed input. Okay, that is a reason why the MP began to decrease. That is really easy. Yeah. Okay, so the whole thing, okay, we learn from this table. Okay, once again, it's called law of diminishing marginal return. So how we verbally, how we state, yeah, law of decreasing marginal return. Yeah, hopefully you guys need to fill this yeah, 4 blanks here. Okay, still remember we are doing short run analysis. Okay, this part is not a long run analysis. Yeah, we seen short run analysis. So it's a variable input added to fixed input. So production output firstly increases and increasing rate at an increasing rate. Yeah, I write down the reason here. What we learned from this video. From that video is a labor specialization. Yeah, what we learned from a food company is a labor specialization can make your production process more and more productive. And then a decreasing rate. Yeah, due to 3 coffee makers is not enough for more units of labor hired. Yeah, finally, the marginal production even can be a negative number. Yeah, when negative increasing rate occurs, like when -9 occurs at here, so total production decreases. Okay, so the whole thing, yeah, is a number A here is called law of diminishing marginal return. So number B, okay, number B actually is in another way. A and B actually is the same thing. Okay, A and B actually is the same thing, guys. Okay, B still can be called the law of decreasing marginal return. We just rephrase number A. To make this a whole definition more shorter, yeah, kind of is a simplified version, just a simplified version of number A. So let's say do number B. So that's a firm as an increasing number of variable resources to fixed resources. The additional outputs added by each unit new variable resources will finally decrease. Okay, so actually, once again, A and B they are just the same thing. Okay, B kind of the simplified version of a law of a diminishing marginal return. Okay, so far any questions? Okay, no questions. Let's move on to next part. We can actually use in another way. We can use a graph. We can use this line graphs, yeah, to represent a lot of dimension marginal return once again. But if before we move on to line graph, we just learn 3 terminology terms we need to use. So in later chapters, when you do the real examination, when you do the segment to save your time, okay, every time you don't need to write down the total production because this whole term down. You just use a TP, okay? It is more easily to just use a TP to represent total production. Okay, AP means average production. So we learned from this table how we calculate AP. AP equals to total production divided by quantity of a variable input. Okay, what is MP? MP is the additional units of products you can produce. Can you send me those number 6 again at the end of the class? Okay. You mean you want notes with the answers, with this field blanks? Okay. Okay, yeah. But you should try to, you should try to fill the blanks by yourself, during the lecture, because the process can really help you to memorize, to understand everything. Then check, okay, yeah. If I directly give you guys the notes with the answers, yeah, basically nobody want to follow the lecture, yeah. Yeah, that is the reason. So TP equals to TP, no, AP equals to TP divided by quantity of a variable input. Okay, MP is the additional output you can produce by what? By hiring just one more unit of labor. Okay, just one more unit of labor. That means by seeing this, so every time in that table is easier because every time the changing variable input just equal to 1. Because I'm saying when you hire one more unit of labor, right? One more unit of labor. So the additional output you can produce, it can be called as MP. Okay, because any number divided by 1 is still is the number. Okay, so the next step, if we graph that table, so how I can graph this table? So I build a coordinate system. I made my horizontal line. I use my horizontal axis to represent the first column here, like how many units labor I hire. And actually, the vertical axis, the unit of your vertical axis, just is a quantity. So I just put a big Q here. Q just means a quantity. Okay, so we graph this table. We just you know how I can graph this curve, so right? I just first I just plot all these points and I connect them together so I can get 3 so-called production curves. So TP, AP, and MP. So for this graph, we still have 3 different kind of parts, 3 different stages of the overall production process. The first one, just like what we did in the table, is called increasing marginal return. So what the first part is called increasing marginal return, because in the first part you see the what? The MP. Where's MP? MP is increasing. Like in the first part, in the first stage, your overall your factory, your business, it can be more productive. Right? What is the reason again? Can somebody repeat what is the reason, like why MP in the first stage it can be increased? Labor specialization, right? Labor specialization. Due to labor specialization, MP in the first stage increases. You see you can see the behavior of the TP in the first stage, right? So the TP here increases and the slope of your TP curve becomes steeper and steeper. I will go into bathroom. Okay. Do I need to? Oh, okay. In the the behavior of a TP in the first part, yeah, you see increase with the increasing rate, yeah, just increase faster and faster. In the second part, in the second stage, okay, second stage is called diminishing. Diminishing just means decreasing, right? Decreasing marginal return. Decreasing marginal return, I mean, you see in the second stage, after this peak, the peak of MP, your MP begins to decrease until to 6 here. But in the second stage, your MP, even though it's a decreasing, still greater than 0. Yeah, because all in the second stage, all your MP, the MP is above your horizontal line. Yeah, so it's greater than 0. Okay, so the accordingly, your TP increase. Still can be increased, yeah, still can be increased, because your MP still is a greater positive number, right? So in the second stage, when you hire more laborers, those additional laborers you hired still can bring out more products, so for sure. So your TP still can be increased, but with a decreasing rate. Okay, but with a decreasing rate, slower and slower, yeah. And then is a peak of a TP. Okay, and then is a peak of the TP. After this peak, okay, your TP begins to decrease. Okay, after when you hire if you hire more worker, like more than the 6 unit of labor, because in the third stage, what is the reason? What is the reason why your TP after this peak begins to decrease? Okay, because the fundamental reason is here, because your MP begins to negative. Okay, finally become a negative number. Okay, this is So the third stage is called negative marginal return. Okay. Okay, so far we got the relationship between, once again, horizontalize the quantitative variable input. Okay, because in that question, in my example, I just assume the variable resource number of workers are hired and the production curves, right? But still remember in the beginning of today's lecture, what the biggest problem we want to deal with in today's lecture is we want to figure out what is the relationship between quantitative output and the cost curves. And the cost curves. Okay, so the graph ultimately we want to get is totally different from this one. Okay, so far the graph, the relationship represented by this graph here, once again, you see the variable lies on the horizontal axis is the number of workers. And all these three curves is about production quantities, is about output level, is about how many units you can produce. Okay, but finally still remember the first graph I did today before we began our formal lecture. We want to get a graph that shows the relationship between ATC and a Q of output. And how I represent what is the unit of the vertical axis? Because this is a cost curve. Because this is a cost curve, so I just label my positive vertical axis by dollar sign. You see this graph and this graph is totally two different graphs. So the next step, how I can convert, how I can translate from the first graph to the second graph. Okay, now I want to do this. Okay, how I can go from the upper half graph, okay, to this final graph we want. How we can find the relationship between output level and the so-called cost curves. Yes, kind of. Yeah, flip it. You are right. Well, how can you know that? How come you know the answer? Okay, but before we flip the curve, okay, we need to define something so-called cost curves. Okay, so the money, so you to tell the difference between fixed costs and the variable costs. Actually, super easy. Okay, the money you paid for fixed resources is called a fixed resource. Okay, the money paid for variable resources the money you paid for variable resources are called variable cost. Okay, and one more mathematical way to define fixed cost and variable cost is fixed cost has no relationship with how many units you produce. Okay, but the variable cost has a relationship with how many units you produce. Okay, my example was in my coffee business, I totally bought 3 units of coffee makers. Okay, if you want to buy coffee makers, for example, I totally paid $300 for 3 coffee makers. So you see, $300 has no relationship with how many units of coffee I produce using 3 coffee makers, right? If I just produce just 1 unit of coffee, just 1 unit of product, 3 coffee makers still is $300 still is $300. Right? If I use 3 coffee makers to produce just okay, maybe 1,000, 10,000 units of coffee. So how much money I spent for purchasing those 3 coffee makers still is $300. You see, $300 has no relationship, does not vary, has no relationship with how many units are produced. But to produce more units of coffee, yeah, 100% for sure, I need to buy more coffee beans, raw materials, yeah, that kind of thing. Yeah. So if you produce more things, your variable cost will increase, okay, but the fixed cost remain unchanged. Okay, so let's define this term. Okay, the first group is called T terms. Okay, can we use the T terms? T means the total. T means the total. T means the total. Okay, T, all this T's means the total. So TFC means the total fixed cost. TVC means the total variable cost. So how you can calculate TC? So you just add these two parts together because we only have two different types of costs, either fixed, either variable. So you just add them up, okay, to get your total cost number. So how I can translate, how I can go from this T terms to A term? All this A means average, right? All this A's mean average. So like AFC means average of fixed cost. AVC means average variable cost. So ATC means average total cost. Okay, how I can calculate? So what is the average of fixed cost? It's a fixed cost per product, right? Per product. So per product, so total fixed cost divided by quantity of output. Okay, AVC equals to TVC divided by quantity of output. ATC, you got two different ways. Okay, you got two different ways to calculate ATC, like a total cost per unit. You either add up AFC and AVC together, or you can do total cost divided by quantity of output. So you got two different ways. Okay, you got two different ways to calculate ATC. Okay, you got two different ways to calculate ATC. Yeah. Okay, last one, what is a marginal cost? Marginal cost is a change in quantity of output. So change in TC divided by change in quantity of output. So another way is the additional money into pay by producing one more unit of product. So one more unit of product, right? That means by seeing this, I make the change in quantity of output equals to 1. So the additional money into pay, that is because that can be called as a change in total cost. Any questions? Any questions about tool number A? Any questions about these terms? No. Okay, if no questions, okay, with no questions, let's go back to our question. Okay, how I can go from this term graph, how I can turn this graph into the graph, which can show the relationship between output and the cost curves. Okay, in step number 1. Okay, in this box, in step number 1, let's do the first step. Okay, this time I need two coordinate system. And you put them together vertically. Okay, please put them vertically, not horizontally. Okay, I label the first horizontal by Q of variable input. In today's example, the variable inputs are always like labor. Yeah, so I add a labor. Okay, and this one is Q. Because the first graph is about the production curves, right? and I label the lower half part horizontal by Q of output. And I label this one by $sign. Okay. So what I'm gonna to do is what I'm gonna to do in the upper half graph is I just copy down from this graph I just want to copy down AP and MP, and in the first graph because we use the raw data, right, the raw data points to get your AP and MP, and this two curve kind of ugly, right? So what I need to do here, I just smooth out them a little bit. I just smooth out them a little bit. So AP will look like this. Okay, I just smooth out the AP. I just copy down. Okay, don't ask me regarding like how I can get my AP look like this. I just copy down. I just copy the graph here. Okay, so AP look like this, and you plot the peak of your AP, and then you add MP. Okay, MP firstly increases and then decreases. But you need to what? You need to make sure. You need to make sure, okay, the intersection of AP and MP should be the peak, should be the maximum point of your AP. We don't need to prove that, okay? We don't need to explain why is the case, because this is simply a mathematical question. You just need to remember, oh, we need to make our MP intersects with AP through the maximum point, like the peak of AP. Okay, then you draw a dot line, extend your dot line all the way down to the lower half part of the graph. And now we can graph two class curves. Okay, the first one is called AVC. Yeah, just like Pong Pong said, we just flip the AP. We just draw a mirror image of AP. Okay, that means there is a inverse relationship between MC and MP, and AVC and AP. So I can draw my AVC look like this. And I'll take a very good graph. Okay, so when AP increases, your MP decreases. When your AP begins to decrease, your AVC begin to increase. Okay, we label this one by ABC. Okay, if MP look like this, then how does your MC look like? Your MC will look like a what? MC looks like a Nike logo, right? Nike, the Okay, and if this is the peak of AP, this one is the minimum point of AVC. Okay, remember this. Okay, I write down here from number one, number two. There's an inverse relationship between MC and MP, and there's an inverse relationship between VC and AP. Then the question is why? Okay, this is a hard question. Why we can flip MP to get MC? Why AVC is a mirror image to AP? How I can get this two inverse relationship? how I can get this two inverse relationship here. Any reason for this two inverse relationship? Okay, the reason actually is this. Okay, because of the wage rate is fixed. Okay, we're just assuming wage is fixed. What do you mean by wage fixed? So by hiring, if you want to hire as a producer, as a business owner, if you hire more workers, every time for those additional workers, you just need to pay same wage rate for those additional units of labor you hire. Okay, and this assumption kind of is a very realistic. Okay, because everybody did come to this coffee shop, come to your coffee business. Everybody kind of do something to do same kind of a job to produce coffee. So in that case, in that situation, right, everybody should get equalized wage rate, just the same wage rate. Let's say $10. Okay, to hire the first unit worker, you just pay $10 for the first unit of labor. And the MP can produce a 5. That means we just add one more column. We just add one more column, it's called MC. So what is the, averagely speaking, what is the additional money you need to pay for these 5 units between 0 and 5? So you do 10 divided by 5, right? So averagely speaking, now you pay now you pay $10 for totally 5 units worker, right? So you do 10 divided by 5. So that means MC now, average speaking, is $2. Okay, but we mentioned here, right? To hire a second of labor, you still pay $10. So 10 divided by 15. But the second of labor can produce 15 units more, right? So 10 divided by 15. So that means that now the MC, averagely speaking, is 0.67, because you do 10 divided by 15. For the third unit of labor, you still pay 10, but this time if you do 10 divided by 25, you see the average cost, the marginal cost has been lowered, is just 14 cents. You see. So when MP increases, due to the wage rate is fixed here, the MC decreases. Yeah, decreases from 2 to only 40 cents. Okay, this is what happened in the first stage. From 4 to 5, yeah, every time each step you still pay 10, you still pay 10, and 10 here. You see, but your marginal production decreases, you see, so your MC begins to increase. So 10 divided by 15, go back to 0.687. So 10 divided by 1, so it's $1. So 10 divided by 2. So the marginal cost for these 2 more units of coffee is pretty high, $5. You see, you got inverse relationship between MP and MC. Okay, you got inverse relationship between MP and MC. Okay, so the reason is which is fixed. Okay, which is fixed. So for any questions from any questions regarding why we can get inverse relationship between MP and MC? No questions. Okay, no questions. Yeah, can we find the what is the last graph? Okay. For this graph, yeah, beside the number 1 and number 2, yeah, 2. And we also mentioned number 4 and number 5. Okay, the intersection are labeled here, right? The intersection of AP and MP should be the maximum point of AP. The intersection of MC and ABC should be the minimum point of ABC. And one more thing we can learn from this question is that if the marginal variable is less than the average variable is decreasing. So I mean, let me show you like what happened in the in this circle. So what happened in this circle? You see, MP is lower than AP. Okay, MP is lower than AP. So the marginal variable, like the marginal version of the variable, marginal projection, if less than average, then currently the behavior we can predict, we can know the behavior of an average variable must be decreasing. Okay, let's repeat again. The marginal variable in this yellow circle is lower than is less than average variable. Then the average variable like AP here is decreasing. Okay, same thing here, right? When the marginal MC be more specific this time, when the marginal variable is lower than the average variable, you see your average variable now must be decreasing again. Okay, decrease. Okay, by contrast, if the marginal variable is greater than AP and this one. Okay, the marginal in this blue circle, if the marginal variable is greater than average variable, then average variable, okay, must be the behavior of average variable, you see, increasing. Okay, let's get more a kind of a more realistic real life example to explain this. Okay, imagine before winter vacation, before Christmas, you need to take 5 finals, and you already finish first 5 finals. You already done the first 4 finals, and the average GPA is 95%. Okay, so 95%, this is called average variable, right? So you got one more term, one more final, one more examination. So the grade you can get here, so the mark, so the score you can get, it can make for your last final, it can be called as a marginal variable. So let's do a what if analysis, all right? So you want to predict, you want to estimate what is the average GPA for totally 5 finals? So 2 situations. In the first situation, if you can get 100% full mark for the last part, for the last final, that means your average for totally 5 finals will increase, right? Your average GPA will increase, like higher than 95%. Another situation, if you only get like 80% for the last examination, so you know the GPA, the average number will go down, will decrease. Easy, right? Okay, so that is how you can understand your number 3 here. Okay, so we need to stop here, and maybe next week we can finish the step 2 graph. If no questions, let's regarding the homework, I remember there is there's a question we can do. Okay, here's a question we can do 2005, the year 2005, all the PDF document on the page number 27. Okay, so page number 27, question 2. Okay, page number 7, question 2. Page number 7. Yeah, that's it. If you don't have any other questions, you are free to leave. Yeah, if you have any questions, you can stay here.